Even I.
Okay, so this is group 8, and we are going to start record our presentation. So I am Yeonhee, and can you introduce yourself, guys?
Yeah.
Go ahead.
I'm Chaitanya Vadhyani.
I'm Sirisha Vemla.
Okay, and we are going to discuss 3 research papers. So one is computing machinery and intelligence. Second is machine learning in Python. And the third is benchmarking contemporary deep learning hardware and frameworks. And the first research paper that I'm going to talk about is computing machinery and intelligence, which is written by Alan Turing. He first proposed the concept of artificial intelligence. Can machines think? Throughout the paper, Turing throws a very critical and probably difficult question: can machines think? To answer the tricky question, he defines the definition of machine and think. So what is a machine? Turing restricts the machines concerned question to imaginable digital computers. He does not straightly claim either all digital computers on the ground can think or a thinking digital computer does exist out there. It is the matter of possibility in our head. The picture on the slide is a digital computer proposed by Charles Babbage named Analytical Engine. The desired requirements for digital computers are store, executive unit, and control. The store is a memory where it contains information and assigns position numbers to its parts. And the executive unit, similar to CPU, carries out operations according to instructions. Then the third one, control, checks if a computer follows instructions constructed by programming. An example of instruction could be multiply the number stored in position 1 by that in 2 and print out the result. The store provides the corresponding information. The executive unit completes the task, and the control observes whether the instruction is correctly followed. Another special property of digital computers is that there are universal machines, which means that they can imitate any discrete state machines. It is easy to understand what is discrete state machine by thinking about the light bulb. The bulb has 2 output signals, which are on and off, and each indicates the internal state of 0 and 1. Continuously jumping from 0 and 1, the bulb turns on and off repeatedly. This is just a simple example, but in the imaginable discrete state machine in the Turing's question has a sufficient number of states. The more states the machine has, the more storage capacity the machine obtains. And the meaning of the term think commonly reflects having opinion or using mind. But when considering the definition, it is not likely to believe that machines can think. However, Turing suggests a game called the imitation game to show his statement is valid. So there are 3 subjects in the game: a woman, man, and interrogator. The woman tries to deceive the interrogator into believing she is not a woman, while the man tries to provide the interrogator with 2 remarks. The interrogator should decide who is woman and who is man after asking questions. What if a machine takes the woman's role and the interrogator fails to make the right identification of the machine as a woman? We should not hastily answer that machine cannot think at the time. This game has been developed into Turing test the test intellectual ability of machine. If the interrogator cannot find out who is machine and who is human, the machine shall pass the test. Thus, the question, can machines think, can be replaced by, can a particular digital computer having enough storage, adequate speed, appropriate programming, sufficiently play the part of A, while a human man takes the part of B. But as it is always, Turing's question stimulates discussion, and he presents 9 arguments opposed to his view. This presentation will discuss a few of them. The first refutation of Turing's view says God has only granted a soul that enables thinking to humans. Turing does not accept the argument because it irreverently restricts the power of God, who can exercise the power to confer a soul to machines as well. They could also say creating a thinking machine is usurping the omnipotence of God, but beliefs held in the past would turn out wrong in the present, as heliocentrism did. The second objection rejects the idea of thinking machine because they simply do not fond of the idea. Turing believes that people on this rejection are not inclined to lose their superiority if, say, higher intellectuality decides higher position. The third objection is related to Gödel's theorem. It shows that in the logical system, there is a statement or statements which is true but not able to be proven, which presents the inconsistency of the system itself. It appears to point out that machines in terms of logical systems are not complete, but it will be rather quite true that machines likewise give wrong or frivolous answers to questions in the imitation game. The fourth objection describes that machines themselves are not conscious of thinking as well as do not feel themselves emotions. Turing argues that it is a solipsistic point of view, and those who support this side will be persuaded to believe thinking machine through the imitation game. The last objection suggests various disabilities of machines, such as challenging, making mistakes, being kind, etc. However, the disabilities mentioned are concluded from one's limited experience, and it could be different in the future. It could be possible in the future. So lastly, Turing proposed learning machines inspired by child education. We humans learn what to do and how to behave from knowledge and experience. And in a similar way, a machine that mimics a child's human mind learns what is good by awards, what is bad, what should be avoided by punishments. The machine will eventually compete with man in the imitation game and be a thinking machine. And it was very interesting that what he imagines in the paper almost comes true today, such as machine learning, the Turing test, and artificial intelligence as thinking machine. And Turing even mentions that after 50 years from 1950, with more than 70% of chance, an interrogator would not identify a machine within 5 minutes of questioning in the imitation game, so that it is no use of discussing the question, can machines think? However, there is a point I would like to make. Is the imitation game sufficient to answer to the question, can machines think? The game, in short, is about the ability of machine to deceive a human interrogator, and deceiving does not refer to thinking. What he or she thinks implies one's intention. I'm thinking about what to write in this note, and this shows that I'm aware of the assignment and intended to complete it. One's intention described by their thinking is not limited to one's subject. In other words, subjects of thinking are various and possibly infinite. On the contrary, a machine thinks in the imitation game with only one purpose, to have the interrogator make the wrong identification. Additionally, the purpose is injected by programmers. So that's all about my part. And thank you.
Thank you, Ek. And sorry. Okay. Can you see my screen?
Now, can you try it again? Okay. Yeah, I can see your screen.
Yeah. Hi, myself is Chaitanya Vadneni. Now, I'm discussing about the machine learning in Python, the programming, how is major take a part in machine learning and data science and artificial intelligence. The research paper is written by Sebastian and Peterson and Nolet. So mainly I'm discussing about what is AI. Do you understand what, first of all, what is AI? It's a question mark to everyone. There is no proper definition for that AI, artificial intelligence. As per my knowledge and the research, AI is a subpart of programming which, uh, sorry, which deals the mission processing inputs and applying the rules that we are not hard coded, and whose accuracy according to some parts along with the presumed novelty and hard-coded rules and giving output defined programming language. And what is the major role of the programming language in the parts of artificial intelligence, machine learning, and deep learning? So here we are discussing about the Python. Python precedes to be the far most favored language for logical computing, data science, and machine learning, boosts both execution and efficiency. So in Python is a high-level interpreted programming language, which is broadly recognized for being simply to learn how to still able to tackle control of system-level programming and languages, which are essential. Apart from this, the benefits of the community have around access tools and libraries of the Python, especially workload, data science, machine learning, and scientific computing as well. And the tools and libraries we are using in Python here, mainly we are using the libraries NumPy and here NumPy and Panda and SigPy we are using. So NumPy is a multi-dimensional library with fundamental linear algebra routines, and both NumPy and Panda provide abstract over a set of data points with operators that apply to full data sets, and the Panda exceeds the NumPy by providing a data framework like architecture that supports column sort, push, and column metadata types. And however, the research paper will relate to those core libraries to provide the logical computing and basic understanding of SecPy stack in recommended to get most out of the study. And numerical computing and data processing. So how we optimize by using the Python performance for both of these. So major logical libraries to be constructed with open BAS integrations, and the manufacture of various CPU instruction set frequently promises the hardware optimization use of BLS and LabPack subroutines. So finally, the provide brief recent advance in the field of learning, indicating that machine learning and preferred learning with become a more robust. And whereas the vital properties in variety of security related real world applications. So and the classical machine learning, we have some scikit learning Python libraries for classical and addressing class mode imbalance and uh, boost mission and model combination and scalable distribution and machine learning. And we have while we are using the deep learning has grown in most popularity in recent years. So machine learning includes addition trees, random foresight, supports vector missions, and several more remains extremely prevalent throughout various research fields and companies. So most widely used open source tool for traditional machine learning. So in addition to its my data management and modeling referred to an estimators. So the scikit-learn developed team evaluate well-established computing for introduction into the library to find the right balance between providing useful functionalities and the ability of maintaining high quality code. So one of the most frequent way to merging modeling in data stacking algorithms, which are prepared to the collection of person models in order to learn how to integrate the individual explorations into one final production. So hyperparameter is sorry. A hyperparameter tuning could be the crucial use case in machine learning involving the preparation and testing shown a variety of configuration to find show the best practice execution and automate machine learning. So everything we are automating by using nowadays. So they have the manual here. The I will show the figures here. The manual process of evaluation and automate way. So we are discussing the two part here. The stage of first one is the stage of auto ML process for selecting and refining traditional machine learning models, and the second one using the neural architecture automate stages are used to create a turn model. So most machine learning pipelines begins with the data presentation step, and which often include the data cleaning, mapping, our user zones to data types and incorrect values in preparation for incorporated making. Several libraries such as HO, AutoML attempts to automate the data type mapping in our organization of data course of action plan by originally collecting various data types. So next, NA is a collection can be used a variety of general purpose optimization and model evaluation methodologies. So GPU and so GPU accelerate data science and machine learning general purpose computing. So machine learning we are using the neural networks are very used on the fast GPU, resulting in substantial speed up above highly optimized CPU equivalent. So the SMIT architecture, like the CPU based SMIT infrastructure, is used by some hardware optimization bias and lab pack implementation works well for parallelizing many of the preventive operations required for machine learning algorithms such as blast subroutine, making GPU acceleration a natural fit. So Rapid is a built on the top of core set of industrial standard Python libraries, substituting CPU-based implementation for GU accelerated ones. The following would influence API fits and varied of arrays for highly powerful APIs in the embedded and interpreted. Oh, okay, the most libraries are commonly used for num PyTorch and TensorFlow for this. This standard is possible to represent the past diverse device memory between the library without having a copy of converting the data files data itself. So deep learning, we have the stages of static data flow graph and dynamic graph libraries with executions and JIT and compare computational efficiency. So we will discuss about deep learning is typically a highlight on representation learning approach. One of the most advantages of deep learning is well adapted to smaller data sets, and DNNs can be large data sets. So the static data, while static computation graphs are appealing for the code optimization and demonstrating set of possibilities from the scenario. The need for the real-time interaction makes the problematic to use in the investigation situations. So the distance between the statement and the execution makes an inactive charts unsustainable for variety of research scenarios. The frequent use thinking and testing. So dynamic dynamic graph abilities, clients can interact with the computation in real time via dynamic computation charts, so which are useful while running or constructing modern profound learning and calculations and architectures. And we have APIs. One of these API keys design goals in providing better road maps between code velocity and customizabilities. And explainability, interpretation, and fairness of machine learning models. So related to this ability to see how model works beneath the hood, whereas interpretability refers to the capacity to see how the changes in input or parameters affected expected outcomes. And Silas expands on this idea by integrating length, a part of predicates along the way from the route to forecast that takes off into the consistent all the methods for the lesson into the rejection results in consists of equation from out of outfits of tree. So here is the main we have privacy. Privacy, on the other hand, does not support both adversarial attacks and defense mechanism, and it is not compatible with TensorFlow or PyTorch. So, but ART works with all three major deep learning frameworks. So MaxNet, Fullbox, and this deep only works with these parts. And adversarial attacks. And so the study also highlights the benefit interaction between the classical machine learning and deep learning, also found install high demand for calculation of including significant modeling and enabling the display of DNNs. So adversarial attacks is the context of security, and learning is strongly related to required the examination of prepared model and learned parameters in order to be better acquire it idea on the security of shows the highlight mapping and choice bounds. So here we have adversarial attack can be have consequences wide range of security applications as well as in physical world. So here we have the two attacks types, white box attacks and black box attacks. White box attacks assumes that attacks is fully aware of approach and DNN architecture. The black box attacks expected for knowing which type of data is take as an input from the attackers and how has no understanding the how the machine learning system operates. So Fullbox and supports all the three major deep learning frameworks, and the so that's it, my point. And okay.
Okay. I'm going to share my screen. Guys, can you Guys, can I audible to you? Am I audible to you?
Yeah.
Okay. Okay. So my topic was benchmarking contemporary uh, deep learning hardware and framework survey of the qualitative metrics. So in this title, as benchmarking means, it means standard. We maintain some standard on the any kind of products to similar things, like we made any product which is seen that is a good or bad. So that's why it's a benchmarking. So now I'm going to discuss deep learning hardware things. Okay. The introduction was, so deep learning hardware. Deep learning is a subset of machine learning, and which is itself subset of artificial intelligence. And in this, we have some things: graphical process units. And graphical process unit is just electronic chip. It is an electronic device. It's a display on electronic device. It's used for the GPU provides the smooth graphics and consume expensive more modern video games. Okay. And it is a different process to receive and execute the instructions from the CPU. And FGPA is the field programmable gate arrays, and it is a dynamic hardware configuration. And hardware engineers use for do usually pronounced as a HDL. And FGPA is the performs GPU in terms of performance per watt and faster than the CPU and GPU for in terms of latency. So coming to the ASIC application, ASIC, it is a application specific integrated circuits, and it is an integrated circuit. It is a designed for a special application. We use for the randomly, it's a kind of memory chips we used in the our PCs. It is just some randomly silicon device. It performs a single logic performance. And then these are main things, mainstream deep learning frameworks. So we have different kind of frameworks here. So one is PyTorch. It is a Python based machine learning package built in a Facebook AI science team. It is enabled from the CPU and GPU operations development technologies. And the next one is Dynet. It is a neural network library. It is written by a C++ language with using the Python interfaces. And KF and the Facebook KF2. The programming language C++ was used to create it. And chain framework. It is also Python based deep learning framework that is also aims to be versatile. And then the KF and Facebook KF2 is the used in the mostly FPGA devices. And then yeah. And the conclusion part is, it is a deep learning. Deep learning is normally in this technique could be used in the classify the images, recognize the speech, and translate the languages and future more. Deep learning is technology is constantly evaluating. And then yeah, what is the qualitative thing is in this deep learning? MLProf is the new pre-element to deep learning benchmark. Organizations measure deep learning hardware performance to use the GPUs and FGPS, ASIS. And deep learning is mainly used for the to recognize the data and future more and translate the languages. That's a main concern. So this is my part. So I'm concluding this part like this.